So we're going to talk about how Taylor series can be used for evaluating indeterminate forms. So specifically, we are going to discuss how we can use Taylor series to evaluate limits. And so just the one thing I'm going to say is that to do this, you're going to want to just be familiar with some common Taylor series. You can pause the video if you want to write these down. So the Taylor series that you see here, so these are common Taylor series, and if you know these by heart, then you could do a lot of other things with them. So let me show you a limit. So here is one particular limit that if you try to evaluate parts of the limit, it might be challenging to do so. You can simplify it. And so one option you have with a limit like this is that you can use a Taylor series to reevaluate it, I guess is what I'm trying to say. So specifically, I look at this and I think, okay, I know the Taylor series for sine of x. So what I can do is I can rearrange this limit. So what I'm going to do is I'm going to bring that 1 over x to the 5th. I'm going to bring that out. And I'm just going to rearrange this because what I'm going to do is I'm going to take the Taylor series of sine of x. I'm going to put it at the end. So I've got negative x plus x to the 3rd over 6 and then this. And now I'm going to replace with the Taylor series here and see what happens. So now I replace sine of x with its Taylor series. And so what's interesting about this now is that there's actually some cancellations that can happen here. So specifically negative x and x to the 3rd over 6, so that cancels out. So these first terms here are all canceling out. And so then I can go ahead and multiply 1 over x to the 5th times what's left. And now that you see this all put together, right, you can also see that x to the 5th is going to make a bunch of cancellations with these exponents here. So I can, cancel out these x to the 5th and then subtract 5 from all these other exponents. So when all is said and done, so remember at the end of the day, I was trying to evaluate a limit. And so if I want to still evaluate that limit, here is now what my limit simplifies to. And what's interesting about this then is if you think about where we started, it seemed like maybe we'd have to do a bunch of different like trig tricks or, just bust out maybe some different limit tricks. And now this thing is actually simplified to something pretty easy to evaluate because ultimately x is going to 0. So all of these x terms, right, are just going to 0. And so what am I left with? Just 1 over 5 factorial, which is 1 over 120. So Taylor series in some cases could actually make evaluating some limits easier. So here's another one. So I've got the limit as x approaches 2 of x squared minus 4 over the natural log of x minus 1. So the other thing I guess I would point out here is that this is also an indeterminate form. The previous one was also an indeterminate form. If you plug in the number, you get 0 over 0. But in this case, so I also want to think about Taylor series. So specifically, if I think about the Taylor series that I know, so I do know this natural log of 1 plus x. So I do know what that one is, and that's not quite the Taylor series that I have, right? So natural log of x plus 1 is equal to this Taylor series. And so now what I need to do is I need to take this x plus 1 and I need to shift it so that instead of being x plus 1, it's x minus 1. And so now you have to think about what are you doing to x to make that happen. And so basically, I'm subtracting 2 from this to make that happen. So if I take x plus 1 minus 2, I will get x minus 1. So now I need to subtract 2 from all of these x's in here to make just the analogous move. So that means that the natural log of x minus 1, it's the same Taylor series. I've just adjusted it, so now it's all x minus 2's here, okay? So going back to what we were looking at before, I can now replace the denominator with my Taylor series. And so right now I'm just going to kind of work out the algebra. We'll ignore the limit for a moment. So you can see now in how this is all lined up that I've got x minus 2 on top and all of these other terms have an x minus 2 in the denominator. So I can definitely cancel out one factor of x minus 2 from everything, right? So I can decrease all of these exponents by 1 to make that happen. So how will this simplify then? Well, then I'm left with x plus 2 on top, x minus 2, just canceling that out, that leaves me with 1. And then I've got the terms that you see here. Okay, so now if I go back and I try to actually evaluate this limit, so now you can see that actually this becomes a lot more straightforward. It may not have seemed like that at first, but remember, I'm plugging in x equals 2. So all of these terms here, when I plug in 2, these all go to 0. And so what am I left with? I am left with 2 plus 2 on top, 1 plus a bunch of zeros on the bottom. So that really just comes out to 4 over 1. And so that whole thing will just equal 4. And so that's how you can use Taylor series to maybe make some indeterminate forms easier. So I'm going to leave it at that, and I'll talk to you guys in another video. Bye.